Welcome, everyone. I hope that you're starting off a good and happy new year in 2011, and I'm glad you could join us this afternoon for our first presentation in our 2011 series on dollar spot disease control and chemical rotation with Dr. Bruce Clark. To get things started, you probably viewed this, but if there's a group that is viewing this from the same computer, if you would please email the information of everyone that's participating in our webinar today to Veronica, as you see here on the screen, and that will assure that everyone gets their credits if they are an accolades member or GCSAA member. And the other thing here that was just reviewed, you can see down here, if you have technical issues, one, you can use the Q&A, but if you lose that, then please call the 866 number you see at the bottom of the screen. As I mentioned, you will be able to receive GCSAA CEUs for this. Expect 6 to 10 days to receive the information, the digital code for this series, and then turn that into GCSAA. For those that are accolades members, you will be able to receive 2,000 accolades points for this presentation, and if you participate in at least 4 of this year's seminars or webinars, you will receive 4,000 bonus points. Here you see we have the calendar of events for 2011 set with the different subjects that will be covered. In the coming weeks, we will be announcing who the speakers are for each of these sessions, and we look forward to presenting these topics that viewers had suggested that we cover for 2011. So if you can put these on your calendar, you'll also be able to find this on our website and in future communications. With that, I want to welcome Dr. Bruce Clark today. I'm sure that everyone is aware of Dr. Clark as Director of Rutgers Center for Turfgrass Science, and is a well-known and well-published turfgrass pathologist. And we're fortunate to have Dr. Clark with us. And Dr. Clark, look forward to your presentation.
Thanks very much, Jimmy. I really appreciate it. And I want to welcome everybody to the webinar today, and I want to thank FAIR and WebEx for giving me this opportunity to present some of our research on dollar spot. Today I'd like to talk about managing dollar spot on golf courses with particular emphasis on fairways, since that seems to be where a lot of people are having issues controlling dollar spot, and talk a little bit about some of the research we've done with good cultural practices and then good chemical practices designed to control this important disease. We all know about dollar spot and the symptomology of dollar spot. It's been around since the 1920s, first identified by Bennett in the UK back in 1934. And we've done quite a bit of work over the years to develop a good set of best management practices for its control, we meaning turfgrass pathologists. From the standpoint of dollar spot, obviously it could be a really tremendous pathogen to combat. It has copious amounts of cobwebby white mycelium, as you can see here in the picture, and this is very prevalent in the early morning hours, particularly in the spring, summer, and fall, depending where you are in the United States. It's interesting that this fungus has no spores, and thus it's amazing that it's such a widespread disease. It doesn't spread by wind currents, it's just spread by plant-to-plant contact. And I think to a large extent this lends itself to the idea that dollar spot is a very good colonizer of the thatch, and it's something that, from the standpoint of disease development, fungus that can colonize the thatch is a good saprophyte, can really survive long periods of time, and I think that's one of the reasons why it's such a widespread problem throughout the country. Dollar spot, the causal agent, we all have learned the pathogen's name is Sclerotinia homeocarpa. There's been a lot of renewed emphasis in the past 5 or 6 years on trying to rename this pathogen, and some work done in collaboration with Dr. Treadway at NC State, and Dr. Bain at Ohio State, and others, including us at Rutgers, have been working very hard to identify isolates from throughout the world and try to determine exactly whether you're dealing with one species of this fungus or whether there are multiple species. And at this point in time, it looks like it's pretty obvious that there's a species that attacks cool season grasses. There's a separate species that attacks warm season grasses, and we should have, I think, this settled out within the next couple of months. So you're likely to see the trade journal article soon renaming this fungus and talking about these 2 distinct species. The conditions favor dollar spot. Interestingly enough, the fungus does overwinter in small, papery, thin sclerotia. They're not the sclerotia in the sense that you think of gray leaf spot, or I shouldn't say gray leaf spot, but gray snow mold, but rather they're small, black, papery, thin globules that attach themselves to the thatch, and these germinate almost like a seed and produce mycelium. Once we hit about 59 degrees, we get resumed growth, and sure enough, we can see that the fungus starts activating, depending where you are in the country, usually in late spring, early summer. It can be a problem throughout the summer months. It just doesn't get too warm. And then we usually have a resurgence of the disease in the fall. And in fact, we've gotten samples from throughout the country almost throughout the year. And it's not unusual now in the past decade or so to see dollar spot developing late into November and even December, depending on where you are in the country. Optimum weather conditions, air temperatures are between 70 and say 80, 45 degrees. The fungus requires high humidity. It lives in the thatch in the off-season, so as soon as the weather conditions are conducive for disease, the fungus moves in the thatch, starts attacking the above-ground portions of the plant, and the disease really becomes severe during periods of low soil moisture, low fertility, and adequate dew. So remember that this is a foliar disease, it's not a root disease, so the fungus needs extended periods of leaf wetness. And so we're talking typically, I would say, anywhere between 9 and 10 hours of consecutive leaf wetness or very high humidity in the turf canopy for a disease to really become severe. I'm going to cover a couple of cultural practices that can be used to reduce the severity of dollar spot. The first slide is really non-controversial. It's sort of logical type information. The second slide is a little more controversial, but we cover the information on the first slide. Obviously, you want to maintain a balanced fertility, and that doesn't really tell you too much. It just says you don't want to stress the turfgrass plant out. This is definitely a stress-related disease, very much like anthracnose. If you have a weakened plant, it tends to be much more susceptible to dollar spot, and therefore maintaining a balanced micro and macronutrient concentration of the plant is important. Maintaining adequate nitrogen when dollar spot is active can help the turfgrass plants recover quickly once fungicide is in place, so that's important. And light, frequent nitrogen applications, spoon feeding programs are really good on greens, and light, frequent applications even on fairways can help smooth out the highs and lows in the fertility program and really help reduce the severity of dollar spot infections. Nitrogen alone can't control the disease, but surely can help reduce the severity. Avoiding drought stress is important. On our research plots at Rutgers, we invariably see this disease showing up first on drier sites, parts of the research trial, and then it moved into the more well-watered sites. So if you can avoid drought stress, it's quite important to do so you prevent setting the stage for infection several days later. Don't irrigate where dusk is something typically we tell landscapers, but I bring it up here only because it brings up the point of leaf wetness and leaf wetness periods. And if you're irrigating or you get say a thunderstorm just before sunset, that ensures the leaves stay wet the entire night long, and essentially you want to try to reduce the leaf wetness period. So trying to avoid getting the foliage just around sunset is a really good approach. It's fine to irrigate once you have dew, and we typically get dew around 11 or 12 o'clock at night. So what you want to try to do there is to try your best to hold off irrigation towards sunset until you have dew, and then it's fine to knock that dew off. The leaves surely can't get any more wet than when you have dew. And you're also not only knocking off the dew, but you're knocking off what's called the patient fluid, which is the sugars that come out from the plant. And dollar spot, like many foliar diseases, really thrives in high sugar content solutions. So irrigating after you have dew is a good approach. Removing dew in early morning hours, not a new suggestion. I think that came out in the 1920s as a suggestion for reducing dollar spot. Many of the foliar diseases, it works quite well in breaking that leaf wetness period. Removing dew by mowing, poling, rolling, or even chemical means, as I'll soon talk about, can really help reduce the intensity of this disease. Removing trees, if you have pocketed greens or fairways which are lined by dense shrubbery or trees, opening up by adding will improve air circulation, removing some trees or shrubs. In terms of greens, going in with fans, even though personally I'm not a big fan of fans, excuse the pun, but they don't look great, but they surely do work, and they've been shown to dramatically reduce the severity of dollar spot and other diseases by just moving that air and helping the site dry out a little bit. Airifying to reduce compaction. I think compaction and thatch is where the fungus resides in the off-season, so you want to keep the thatch to a minimum, and reducing the compaction will improve plant health and therefore reduce the stress-related disease like dollar spot and even anthrax. This is a picture from my good friend Keith Happ, essentially showing dragging the fairways with a modified system where you drag it with a golf cart. Really, this is an opportunity at fairways to reduce the leaf wetness period. Obviously, you don't mow fairways every day like you do greens, and therefore going out and removing the dew when you're not mowing can help the turf dry out quicker and can, in fact, reduce dollar spot severity. So it's a good practice if you have the manpower to do so. The slide here you're looking at is actually a chemical approach to reducing dew formation. Dew Cure is a product, there are many products out there which will reduce dew formation, and this is one of them we've looked at. And in this particular slide, on the left axis you have number of dollar spots per plot, and on the bottom axis you have the dates. And in this particular year we applied Dew Cure starting in May, and they continued every 14 days. And you can see that it did, in fact, pretty dramatically reduce the severity of dollar spot. It didn't control dollar spot, but it did reduce it. And in fact, the blue line, which is the amount of disease with Dew Cure, is pretty much a mirror image of the red line, which is the untreated turf. And so essentially you're taking the disease down a notch, if you will, simply by reducing that leaf wetness period. And by doing so, you're reducing disease severity. So this is the same type of approach you would get if you drag or pull the greens or drag the fairways, but this is another chemical approach of getting to the same spot. So it doesn't control the disease, but it surely makes the fungicides work better because you're reducing disease severity. The next slide is a little bit more controversial. There have been a lot of work, a lot of questions I've gotten over the years in terms of do organic fertilizers, composts work really well on reducing dollar spot? And the answer to a large extent is yes, they do. You can reduce disease severity. Peter Jerdot and some other people have done some extensive work on this. And a very interesting article a number of years back, Peter and his group at University of Maryland actually showed that the organic fertilizers, the composted materials do reduce disease. But as you can see here, they do so to a large extent because of their nitrogen they add to the system. So organic fertilizers and compost can reduce dollar spot, but this is really more due to increased availability of nitrogen than to the microbes that might be adding to the soil. Now, this doesn't mean that the microbes in these products aren't important. It just means that in most cases, when you compare these products in head-to-head tests with synthetic nitrogen sources at the same rates, they pretty much provide the same level of control as a synthetic nitrogen, and therefore, this is to a large extent, related to nitrogen improving the plant's vigor, reducing disease severity. Now, having said that, there are products on the market which can reduce dollar spot. These are microbial inoculants, if you will, biological organisms that you would add to the field. Some work done by Eric Nelson over the past decade or two has shown that beneficial bacteria like Enterobacter or Bacillus can in fact reduce disease severity, but in most cases they only work well, number one, on a preventive basis, and they generally don't work very well once disease pressure really starts to increase. They do well at, say, lower to moderate levels of dollar spot. There are some products that are currently on the market today which will reduce dollar spot. The trichoderma, which is a beneficial fungus, sold under the trade names Root Shield, Turf Shield, or BioTrek, does a nice job in reducing dollar spot severity under mild conditions, as will the Bacillus licheniformis, which is sold Eco-Guard, will also do the same thing. Both of these products, just as the BioJect system, which contained the Pseudomonas verifications, many of you may remember that, all of these products generally will suppress dollar spot at low levels. They need to be applied on a preventive basis rather than a curative basis. And once the weather conditions are conducive for severe dollar spot pressure, you need to apply either tank mix or alternate in some synthetic fungicides. They just cannot keep the disease pressure back under really severe conditions alone. And last but not least, using new and improved bentgrass cultivars. And if you haven't looked lately at some of the new cultivars on the market, you really should, because the breeders have done a superb job over the past 5 or 6 years of releasing some superior bentgrass cultivars for dollar spot tolerance. I'm not talking about the A and G series. I'm talking about newer cultivars like Declaration, for instance, 007, which have a distinct improvement in dollar spot resistance or tolerance. They're not completely resistant to dollar spot, but they're head and shoulders over grasses like Crenshaw and 18th Green, which are very susceptible cultivars, and even much better improvement over some of the newer A and G series. So they're worth considering if you're putting in new areas, renovating areas. It's worth looking at some of these grasses, particularly if you have severe dollar spot pressure and a history of dollar spot control problems with fungicides. This gives you an example of some of the new cultivars I'm talking about. This came from some NPEP results that Rutgers has participated in over the years, and you can see here that we have excellent resistance or tolerance to dollar spot with products like 007, products like varieties like Benchmark, Declaration, Kingpin. These are new, improved type cultivars where the breeders have spent a long time trying to develop resistance, and to a large extent have done a superb job in being able to reduce the severity by simply gravitating to some new, improved bentgrass releases.
So, Dr. Clark.
Yes.
A question that might be better answered right now, there's a question about what about alpha and T1?
I'll go back to that slide if I can. The alpha and well, you can see alpha is moderately susceptible. And I would say this, that, if you're looking at the NTEP results, you really should look to see how well these cultivars do in your particular area or in an area that's similar weather conditions or environmental conditions. Because alpha may be a fine grass for certain parts of the country, but if you stack it head-to-head with something like Declaration, it tends to be much more susceptible to dollar spot. Okay. If there aren't any other questions right now to pick up on, what I'll do is just give you a picture here, and it gives you an example of a new cultivar like Declaration compared to 18th Green. And surely you get dollar spot on declaration. You just don't get as much. It takes longer to come in. And I think that's what everybody's looking for, is to just bring the disease down a notch so that the fungicides can work more effectively. So these are some of the cultural practices that we found work quite well. Most of them are pretty logical, nothing really earth-shattering or rocket science, but taken together, they can significantly reduce the severity of this problem on greens and both greens and fairways. We talk about chemicals, and I'd like to spend the remainder of time talking about chemical control of dollar spot. There are a number of chemistries which are well known to control disease, particularly dollar spot. But some of these compounds have had resistance issues. The benzimidazoles, I think, are a prime example of products that have resistance issues. Not all golf courses will have resistant dollar spot isolates to the benzimidazoles, but the great majority do in fact have resistance isolates on their golf course to this group of chemicals, mainly because of the biochemical mode of action. It's a single site mode of action. It's controlled by one gene. And it's very high probability of resistance. We have also had some issues on resistance issues to the dicarboxamides and also the DMI fungicides. Basically, the DMI fungicides, such as your Banner, Balaton, Eagle, Rubigan, Triton-type materials, are materials which are very effective against dollar spot at usually fairly low rates. We've seen some resistance to them, but not nearly the extent that we've seen with the benzimidazoles. We've also seen some, as I said, some resistance issues with the dicarboxamides, such as Piperdown or the vinclozolin type products. But interestingly enough, the strains that develop resistance in this class of chemistry tend not to overwinter all that well, and within a couple of years you can often put those type of products back into your rotation for dollar spot and still get control. Whereas the benzimidazoles, those strains are resistant for 10, 15, 20 years. They're very, very persistent isolates. We have the old contacts, the diethylcarbamates, such as your 4 and diethane type products, which do a nice job in suppressing dollar spot but for a very short period of time. We're talking in a matter of 5 days, 7 days, maybe a little longer, depending on how quickly the grass is growing and the weather conditions. The nitriles are another contact group which really form the backbone of control for dollar spot, anthracnose, and many other diseases. There's no resistance to those reported. They're multi-site fungicides. But the problem with that is that the EPA has been restricting the amount you can use, and therefore we're always looking for other products to rotate in for dollar spot control. One of the newer chemistries, the carboxamides, osculate or emerald, is one of the newer entries in this. We're sure to see many additional products coming in like this within this chemistry. They're very narrow spectrum. Osculate only controls dollar spot and nothing else. And the probability of resistance, although we haven't seen resistance in turf yet, is always there. There are reports of resistance to boscalid in other crops, such as pistachio and some other agronomic crops, and so we have to be very careful in turf using this type of chemistry properly. You don't want to use sequential applications of something like boscalid. You want to continue to use alternation and tank mixing strategies to reduce the potential for resistance, and we'll talk about that a little bit later. And then finally, the QOIs. And the QOIs are a very broad spectrum chemistry. Products like Insignia, Disarm, and Compass are very effective for a number of diseases. Bread and butter diseases for this group would definitely be the root diseases, your summer patch, your K-fall patch, even some of the warm season root diseases. But really, when it comes right down to it, they will suppress dollar spot as well. I would never utilize this chemistry as my main means of defense. They will suppress dollar spot, products like Insignia and Disarm, but the probability of resistance if you overuse these is definitely there. So I would just factor those into your disease control program for other diseases, knowing that you'll get some side benefit of dollar spot suppression with the QOI type fungicides. And then also we have the combinations. There are a number of premixes out on the market today. Many of them do a nice job in suppressing a number of diseases. A good example of a combination which does a great job in controlling dollar spot would be Interface. Interface is a combination of iprodione, which is dicarbonamide, and trifloxystrobin, which is a strobilurin fungicide. You get broad spectrum control of a number of diseases, and dollar spot is one of them. If I show you some data from Rutgers over the past few years, a good example would be some data from 2009. And we looked at the effect of selective fungicides on dollar spot development on creeping bentgrass green in this particular instance. And you can see that the black line is just the untreated, and it has a tremendous amount of disease, peaking at about 175 dollar spots per 3 by 9 foot plot. And the fungicides listed here, from Daconil down to tartan, were applied at 14-day intervals starting the end of May and continued through the end of July. And you can see that we're getting excellent disease control with products like chlorothalonil, as well as the Interface products, which again are combinations of iprodione and the trifloxystrobin, from very low rates, as low as, over here, let me go a little over here, but as low as 3 fluid ounces all the way to 7 fluid ounces, and essentially all of these in this particular study giving us great control. If you look at it, comparing it to the iprodione Pro, which is iprodione product, you're seeing that after the applications stop on July 30th, that we get a resurgence of disease with that individual product, whereas the tank mix or premix combination of Interface giving us excellent control right through the end of the study. So, you know, the tank mixes or premixes can do a very nice job, and in many cases are more effective than individual products alone, particularly when you're talking about residual control after several applications. Here's an example of turf quality and some of these materials I just showed you. You can see turf quality, 9 being best turf quality and 5 being acceptable turf quality. We don't have acceptable turf quality with the untreated. We have a turf quality of about 3.5, which is very poor. Whereas with some of the other products, such as the Interface, at the highest rate, we're getting a turf quality of about 8.5, which is 9 is perfect, and you know, just excellent quality with the premixes. Very good quality with a product like tartan, and then the individual products, the iprodione Pro and the Daconil, giving acceptable turf quality, but far reduced compared to the tank or premixes. So, you know, for hard to control diseases, you know, factoring in tank mixes or premixes can really help reduce disease severity compared to individual products, and they broaden the spectrum of control to many other diseases. So it's often a good approach for disease control. If we go to 2010, looking at some additional data, we're looking at products like tartan and emerald. The Interface is an example of premix combinations, and the individual products of Daconil, and then tank mix combination of Insignia and Trinity. We're seeing the same type of thing. The black line, which is the untreated, you can see here getting very high disease pressure. These products again applied toward the end of May and continued through, in this case, the first week in August, getting us, you know, good control. I'd say anything below 10 on this chart would be commercially acceptable. And you can see that you're starting to get a little bit of breakdown in late July, early August with the Daconil, but the combination products like Interface or tartan or even the Insignia Trinity are giving us good control right through the end of the season. A little bit of breakdown here with the Insignia and the Trinity later on, but that was about 14 days or so after the final application. So you don't eradicate these fungi, that's for sure. You just suppress them until the weather conditions are no longer conducive to this disease. And then just looking at the quality for the slide I just showed you, the same type of thing as you saw before. You have, you know, products like Boscolid, which are very strong dollar spot materials. The interface at the higher and middle rates giving, essentially statistically equivalent control, and then the lower control with the single product applications like the chlorothalonil. And this is compared to the untreated, which has a turf quality of about a 3. Remembering that at 5 is about, in our ratings, is about the minimum for acceptable turf quality. And then it's finishing up with some fungicide data for fairways. We just looked at some greens data, looking at some fairway data. This is 2010 from this past summer. We had fairly high disease pressure, about $50 spots per plot on the untreated. And these plots, again, the treatment started the end of May and went through to the first week in August. And you can see just, spectacular control through June, July, and then you start getting into late July and August when the treatments stop, and you can see maybe the lowest rate of interface starts to break down a little bit, but still below that 10% threshold or the $10 spot threshold that we use for acceptable control. And then, about 14 days later or so, you're out 12, 14 days later, a lot of these products start to break down. You can see the Ipodome Pro breaking down. You can see the lowest rate of the interface starting to break down. And it's the better treatments would be the higher rates, in this case, the higher rates of interface, such as the 6 fluid ounces or the 5 fluid ounces, staying below that $10 spot threshold that we were talking about earlier. So there's 2 ways to look at it. It's control while you're applying it in a certain sequence, like every 14 days, and then it's looking at residual control and how long you expect these products to last. It's usually the higher rates last longer, obviously. And then finally, looking at turf quality for the slide, we just looked at the same type of thing. Getting excellent turf quality with the higher rates of the interface of the tartan. Even Ipodome Pro in this case giving us very good turf quality. And the only thing that's not working well, obviously, is untreated, and even that in this particular trial, when we took the ratings on the last application date, the disease pressure hadn't picked up to the point where we were getting, awful quality. Okay, if we move on then, I'd like to get into an area which I borrowed some slides here from a couple of colleagues, Peter Cannone at University of Maryland and John Kaminsky at now at Penn State University, and Mike Fidanza at Penn State, and Mike being at Ohio State, where we all work together, and I try to pull some of their data as well as our data to try to give you an idea of how you can tweak your fungicide program and improve fungicide performance. And some of the things I'd like to talk about today, I won't have time to get into disease predictive models, but I'd like to spend some time talking about water volume and dew removal and how that influences fungicide control. Talk a little bit about some of the work we've done with nozzle selection. And then, finish up with such things as the effect of water pH and wash-off on disease development. And also finish up with a little bit of data on, our early spring applications of fungicides, way before you see symptoms develop. Are they really worthwhile? So let's start off with some of the work on water volume and dew removal. And to do this, I'm going to talk about some research that was done at the University of Maryland by Peter Jernodin and Steve McDonald back in 2007. They did an interesting study where they looked at the effect of water volume and dew removal on the control of dollar spot with 2 different fungicide chemistries. One was a contact chemistry, such as chlorothalonil. The other one was a penetrant type chemistry, such as propiconazole. And if you look at some of this data, and you look at some of the pictures, very interesting idea. Essentially, number one, they were looking at the influence of water volume on fungicide efficacy, and looking at chlorothalonil at a very low rate. I can look at Dicanyl Ultrex as an example here at 1.8 ounces. It was applied every 21 days, which is really stretching a low rate of a contact fungicide, but they wanted to see a break. And they wanted to see, under these conditions, which was the better rate of water. And what they found on fairways here essentially was that they found they got better control of dollar spot when applied at 1.2 gallons under low to moderate disease severity. Now, that may seem a little bit surprising, better at 1.2 than 2.5, but you can see the pictures here. Here's disease development, a little bit of dollar spot here and here with 1.2 gallons per thousand, and you can see a lot more dollar spots showing up with the 2.5 gallons. Now, the key words here are low to moderate disease severity. Under higher disease severity, I would say that our research has shown that you really need to increase the water volume or increase the quantity of fungicide you're putting in, the rate of the fungicide. But here is a good example under low to moderate disease pressure, getting, not only good control, but even better control to lower water volume with this compact fungicide. So, interesting results from Peter Noden and Steve McDonald. Looking at the influence of dew removal, this is one of the first times I've actually seen anybody look at the question, does dew removal, is that important in terms of applying a fungicide? And what they did here, they looked at two different chemistries. So the first slide here, we see chlorothalonil at 1.8 ounces and 1.2 gallons of water. And they actually, the result of this work, they showed they got better dollar spot control when dew was first removed in early morning hours. So you can see where you have no dew, essentially the fungicide was, they waited until they removed the dew or dew dried, and they got very few dollar spots showing up. But where they actually went in and oversprayed the daconil on top of dew, they got much more disease development. And they pretty much theorized that the reason was that dew prevents contact fungicides from spreading over the leaf to provide complete protection. And that makes a lot of sense. Essentially, contact is a prophylactic. It's got to coat the leaf to be effective. And if the contact hits a dew droplet and rolls off into the thatch, it's not going to provide adequate control of dollar spots. So it's pretty logical, but it's the first time I've ever seen anybody actually prove that dew removal was important before you apply the contact material. Now, if you looked at a penetrant material, there was no difference. There was no effect of removing dew on fungicide efficacy for dollar spot control when looking at propiconazole, in this case, a very low rate of countermax, applied at 1.2 gallons of water. Again, on 21-day intervals, trying to see a breakdown, and literally getting very good control with whether you applied the propiconazole on top of dew or whether you waited until it dried off or you removed it. So essentially what you're seeing here is that for a penetrant fungicide, it really doesn't seem to matter. If it hits the dew droplet, rolls off into the base of the plant, as long as it hits a root or a stem, if it's absorbed and it moves upwards, you get good control. So the answer to the question, is dew removal important? It really depends on whether you're dealing with a contact or a penetrant fungicide. Recommendations here, recommendations for what we just talked about. I think for contact fungicides, using 1 to 2 gallons of water is an ideal water volume. Using a lower rate, 1 to 1.2 gallons per thousand, as long as you have low disease pressure, I think is fine. Under high disease pressure, you either have to increase your fungicide rate or go into 2 gallons with our research to get that kind of control. Removing dew to improve performance is very important apparently for contact fungicides, but doesn't seem to be very important for the penetrants. So if you're dealing with a fungicide that is a contact a mode of action, you may be better off waiting until the dew dries off or dragging the fairway and letting it dry off that way before you apply the fungicide to try to improve the level of control. And then one of the things they talked about in their study, which I didn't have time to show you the data, but the summary conclusion was that the tank mixture of chlorothalonil and propiconazole at reduced rates gave better control than either product alone under high disease pressure. And we've seen that time and time again with most of our foliar disease studies, such as dollar spot or anthracnose. The tank mix combinations seem to give better control. And the reason for that is because you're not controlling just one strain or one isolate. You have many, many different isolates of dollar spot on your range and fairways, each one with a different level of susceptibility to a different fungicide group. By tank mixing, you're going after different isolates with different chemistries. And then under very severe pressure, research at Rutgers has shown pretty clearly that you either have to go at higher gallonage, like 2 gallons of water, or increasing your fungicide rate to a higher concentration at a lower water volume. If we continue on then, we look at nozzle selection and its impact on fungicide control. Some interesting work done by John Tominski, Mike Bedanza, and others, as well as us, on this has shown clearly that the flat band are far superior to the hollow cone spray nozzles for foliar disease control. And the main reason is that the hollow cone nozzles, like the old raindrop nozzles, create very large water droplets, and large, coarse or very extremely coarse water droplets tend to be very effective for root diseases and getting a lot of water on deep into to penetrate into the thatch, into the roots is fine. But for foliar diseases, particularly with contact fungicides, we've seen that flat bands have been superior, and in fact certain flat bands, such as the extended range and the air induction nozzles, have shown particular benefits, which we'll talk about in a moment. Here's an example of spray coverage. We're seeing spray coverage from the standpoint of nozzle type. If you look at a TJEC catalog, you'll see there are a wide selection of nozzles within each of these nozzle types, and depending on the color of the nozzle tip, it'll tell you essentially how coarse or fine those water droplets are. But for instance, an extended range nozzle with a fine to medium water droplet size gives you very good to excellent spray coverage, as does the Turbo T-Jet and air induction nozzle. But the more coarse water droplets, such as the raindrop nozzle, the hollow cone nozzle, or the turf jet nozzle, are extremely coarse droplets and give you relatively poor coverage. Now, if you look at water-sensitive paper here, you can see essentially what we're saying. I mean, we have the raindrop nozzles, turf jet nozzles giving you very coarse droplets. Anything that's yellow or goldenrod in this picture, or these pictures, would be lack of coverage. So if this were a leaf, you could see how a lot of areas are just not covered with these two nozzles, whereas the extended range nozzle or the air induction nozzle give you very good control and very good coverage here because the droplets are finer and they tend to be closer spacing. So essentially, the extended range air induction nozzles give you good coverage and translating into often good disease control. If you look at the flip side of that coin, you have the raindrop nozzles, the turf jet nozzles giving you excellent drift control because they're big water droplets, but the extended range, with a fine to medium droplet size, not as great drift control, and even a turbo T-Jet not as good. So the only thing I'll mention here, and that is this is a picture of the air induction nozzle. You kind of get the best of both worlds. It gave you good coverage, and also you can see right about here, excellent drift control. And so I'd like to spend a minute and just talk a little bit about the air induction nozzle. I know many of you have started to utilize that. It's a nice hybrid nozzle that has a unique design in it. And if you actually took a cross-section of an air induction nozzle and looked at it, you'd see that you have the spray would go from the tip of the nozzle through the base of the nozzle, and when it gets to the center, that spray is being constricted. So the little pipe where the spray solution is going through actually constricts and acts like a venturi. Remember your high school science, when you constrict an opening, the rate or the speed of that fluid going through that opening actually speeds up. And as it speeds up, it actually will suck in an air molecule right through the hole that's located on the outside of this unit and allows the droplets to be actually the air molecule being encased in a fungicide solution such that you have larger droplet sizes coming out of that air induction nozzle, therefore reducing the movement from wind and better drift control. But as soon as it lands on the leaf, as you can see here, it's breaking or shattering into small little droplets. So essentially what you're seeing here is a situation where you have many small droplets covering the leaf surface, and you have the advantage of a good drift control and then also good coverage. So It's a unique nozzle. It's a very good nozzle. If you haven't tried it for foliar diseases, it's a good choice. I like to put together what we just talked about. We talked about water volume. We talked about nozzle selection. A number of years back, we had some demonstrations at our turf field day, and I just mentioned a few things here. Looking at the impact of water volume and nozzle type at a very low water volume. This is a half gallon per 1,000 of chlorobalaenol at a very low rate, 1.8 ounces. And we're looking at different nozzles such as the air induction nozzle, the turbo turf jet, the extended range nozzle, and then the Delvan, which is the old raindrop nozzle, the hollow cone nozzle. You can see that you're getting very poor control with a hollow cone nozzle, essentially almost equivalent to the untreated, whereas you're getting better control with either the air induction, the turbo, or the extended range. Now, follow the height of these bars here when we change from a half gallon of water to our next slide, which is 1 gallon of water. The height goes from this point, it goes down. And that's the reason for that is you're getting better coverage from half to 1 gallon. Even the Delvan nozzle is a little bit better, but nothing to write home about. And then as you go from 1 gallon to 2 gallons under higher disease pressure, you're actually seeing a slight improvement with many of these nozzles. So the take-home message is essentially that, nozzles and water volume are important, and that with the better nozzles, such as air induction, the extended range nozzles, going between 1 and 2 gallons really is ideal. The Delvan nozzles, surprisingly enough, you'd have to go through about 4 to 5 gallons of water per 1,000 to get equivalent levels of control. We've done some work with wash-off studies. I get a lot of questions from superintendents. What happens if I apply a fungicide and then I get a heavy rainstorm within, a few minutes or, an hour before the solution has a chance to dry on the leaf blade, do I have to retreat? And so we looked at a number of different chemistries here. We looked at chlorobalaenol, we looked at contact, we looked at 2,6-GT, which is dicarboxamide, which is a localized penetrant. We looked at one of the DMIs. We looked at a premix combination of one of the strobies. And we looked at either immediately following the application with a half-inch of rain within 5 minutes. In some treatments, or some crops, we wait 4 hours. In other crops, we wait 24 hours. And in some cases, we just would not apply any irrigation. And if you take a look at some of the results, not surprising. Here's a poor slide of me that just I put this in here just to show you what we did in terms of applying irrigation. It was a handheld hose with a gauge on it, so we could gauge out exactly half-inch of rainfall in these plots. And again, these were applied either right away, 4 hours later, or 24 hours later. And look at a couple of pictures. You can see the effect of post-treatment irrigation, in this case immediately following with a half-inch of rainfall or irrigation here on one of the products like 2,6-GT. With no irrigation, we have very few dollar spots showing up, and with immediately following it, as soon as we applied the fungicide, immediately following with irrigation, within 5 minutes, we had a lot more dollar spot. Now, much less than with the untreated, but you're seeing a dramatic reduction in control with this localized penetrant before it's allowed to dry on the leaf blades. If you waited, if you looked at 4 hours later, once the product had a chance to dry, essentially equivalent to no irrigation at all. Very few dollar spots here. The untreated, you can see, extensive pitting and extensive disease development. So, the summary then from this work was essentially that all the fungicides reduced dollar spot, obviously, but all the fungicides were impacted by watering after treatment, some more and some less. The contact chlorobalaenol or Dacno was most severely affected by immediately irrigating it, which is what to be expected. The localized penetrant appeared to be the best treatment after about 4 hours of waiting 4 hours for the rainfall. So something like 2,6-GT, if you have rainfall within about 4 hours, you could expect essentially equivalent control to no rainfall. To finish up then with one of the other items, which was water pH. We've known that for years that certain fungicide classes are very susceptible of being tied up or deactivated at higher pHs. You can see here that to a large extent most pesticides and most fungicides are stable between 4 and 6 pH. Some fungicides actually decompose at pHs above 7. The reason for this is a chemical process called alkaline hydrolysis, which chemically breaks down fungicides that are sensitive. Good examples of very sensitive chemistries would be the polyoxin D-type products. Methionate methyls are very susceptible to alkaline hydrolysis. And if you're concerned about whether your product is pH stable at higher pHs, check the MSDS sheet. We did some demonstration work at some of our field days, and we looked at the impact of different water pHs on the benzimidazole 3336, and found that we got excellent control at pHs of 5 and 7, but a quite significant reduction in control at a pH of 9. It's still better than the untreated, but a significant breakdown in control just simply by mixing that product in with a lower pH and then spraying it right out, so it didn't even sit around very long. If we looked at another study which was done by Mike Panza looking at different water pHs on chlorothalonil, the contact, surprisingly, it is affected at pHs above 7 pretty significantly, reducing it at 8.5 and at 10, essentially equivalent to untreated. So, I wasn't really thinking that chlorothalonil would be affected by pH as much as it is, but at pHs above 7, you can see fairly significant drop-offs in disease control. Just to go back for a second, I didn't put a slide in here, but the penetrant propiconazole in the same study was not affected at all by pHs. So the DMIs don't seem to be affected by water pH, whereas the chlorothalonil and the benzimidazoles are something to be concerned about. And last but not least, the question I've gotten from a lot of superintendents, because they've seen our work and work from John Kaminsky and Mike Bain and others with early spring applications is, should you be reapplying or be applying a fungicide in the early spring, just around green up, well before dollar spot typically develops? Is there any use to doing that? And I think to a large extent, we've seen some really benefits if it's a well-timed application with a good dollar spot fungicide. There's some pictures. Here's one picture here from a study done at Ohio State University on a commercial golf course where they had no early spring applications, and you can see the outline of the plots here. A lot of dollar spots showing up on July 7th with no prior fungicide applications. And if you look at the area that's essentially just below the area we just looked at, this is the area where they had applied one early spring application. And you can see above, we have a tremendous amount of disease. We have very little disease in this plot where they applied one early spring application in April, and then by July 7th, when this picture was taken, seeing a fairly significant decrease in disease development. And I think that's what you're looking for. I would say the key here is to apply a good fungicide. I'll get to some suggestions in a moment. Apply a good fungicide on your fairway in the spring when you start to get green up. Put a piece of plywood out here. If you put a piece of plywood where I put the pointer and you overspray it, come back later on when you see disease development in late spring, early summer, and you can't see the outline of the plywood sheet, it's not working for you. If you can see distinctly where you put the plywood sheet and it looks like this area, then you know you have a benefit from applying the one early season application. This is the last graph I have, the last table, but it's probably one of the best examples I know of. And this was done by John Kaminsky when he was at University of Connecticut. It's the effect of early season applications of single application of various fungicides on dollar spot suppression. This was done with the product enclosalin, which is Curelan, propiconazole or Banner, Oscillid, Emerald, Balaton, and so on. And essentially what you're seeing here is that one application made on April 13th. They started seeing disease development June 6th, which was essentially 7.7 weeks after that application. And they're seeing some significant suppression of dollar spot here with Curelan, only $1 spot per plot, banner or emerald or balaton, $6 to $11 spots per plot. If it has the same letter, essentially it's statistically equivalent. So the first 4 products here are giving you equivalent levels of the dollar spot control compared to the untreated, $89 spots per plot. 9.7 weeks later, rating on June 20th, still great suppression compared to the untreated. The untreated is $87 spots per plot. Pureland, the banner, the emerald, the balaton, the chiplet 262T, giving equivalent levels of control. And sure enough, you can see the benefits of that one well-timed application. So our recommendation then is to simply go in and apply one early spring application with a good dollar spot fungicide, such as the ones we just mentioned, or better yet, a tank mix of 2 good materials at say mid-label rates applied after the second true mowing. And by second true mowing, what I'm essentially talking about here is where you're applying the fungicide after the grass starts to grow. The first mowing, you get a lot of just winter desiccation, not much in the way of leaf tissue. But if you were collecting clippings, the second true mowing, you're actually collecting, good, healthy, new green clippings. That's when you want to get the fungicide out, and that's just one application. And essentially, what we're seeing here is improved levels of control pushes the disease back, and when it does occur, the severity is usually less. Now, whether that translates into less fungicide use is another question, but surely it will reduce the severity of some of these early outbreaks, which I think everybody is interested in doing. As far as late fall applications, we haven't had great success with this. It's really somewhat of a crapshoot in terms of when to apply them in late fall, and in most cases, it's a lot to expect, I think, to see an application or 2 made in the fall translate into reduced dollar spot 6-7 months later. So if I had to make a suggestion, if you have enough money in your budget for one additional application for dollar spot control, I would definitely try the one early season application rather than chancing it with additional fall applications. And with that in mind, I think I'll stop. If we have time for some questions, I'd be happy to answer them. I just want to thank you very much for listening, and I'll give a plug for our turf research field days on July 26th and July 27th. We'd love to see you out there, and we have a lot to show this coming year.
All right. Thank you, Dr. Clark. We do have some questions. First, and this was actually one of the questions, we will post this presentation to backbybear.com. That should occur within 2 weeks, and all of the Bear Beyond the Basics webinars are posted to backbybear.com. We do have some questions, and we will try to answer those for anyone who wants to stay around, and I'll start it with the first question. Does sand top dressing have an impact on leaf wetness?
Well, I tell you, we've done a lot of sand top dressing work for anthracnose control, and I can tell you it definitely reduces a disease like anthracnose. In terms of leaf wetness, or in terms of wetness of the soil, obviously, I think if you have sand, if you have a sand profile, you're getting better drainage. But I mean, I would answer that question from the perspective: does it affect disease development? And it surely does affect anthracnose reduction. I haven't seen very much work in terms of dollar spot, but that's certainly a possibility as well. I think generally, it's just a good agronomic practice that it's going to improve plant vigor. It's going to improve the firmness of the heading surface, and therefore, I think is a good approach for diseases such as these stress-related problems.
I have the next question, Dr. Clark. In the effort of removing dew, is there any development of an adjuvant that can be added to increase leaf exposure?
Exposure or leaf improve the leaf reduce leaf wetness? Did you say exposure or?
Yes, I think he said exposure, but
okay. Well, then I'll take it from the standpoint that I'm sorry, go ahead.
Please take the question.
Okay. You know, from the standpoint of adjuvants, there are a lot of materials out there which can break the surface tension on a leaf. Surely those could be used to you know, disperse, you know, dew or to improve the spreading of a fungicide, to improve fungicide control. You know, from the standpoint of that dew cure type product, that was actually to prevent dew formation, which is a little bit different. And we were looking at that to try to reduce the leaf wetness period. But there are a lot of different products out there. They have different qualities, and we've only looked at a couple of them. But I used the dew cure as an example of a chemical approach to reducing the leaf wetness period.
The next question, they're asking for an easy way to differentiate between dollar spot and bentgrass dead spot, as they sometimes have a difficult time determining which.
That's a great question. Yeah, basically, it's very simple if you look carefully. I mean, dollar spot and bentgrass dead spot, the spots can be quite similar when they first start. Bentgrass dead spots on a green, though, actually can get quite large. They can get to about 3, maybe 4 inches max, whereas dollar spots rarely on a green will get much more than, say, 3/4 of an inch or more, maybe an inch at most. They will coalesce and come together. One of the easiest ways, though, to tell the difference, really, would be to look at the periphery of the spot. A very active bentgrass dead spot would have sort of a bronzed appearance, whereas a dollar spot is always sort of a, you know, a bleached white appearance. And then finally, last but not least, if you have a good hand lens, and you have bentgrass dead spot, look at the individual plants that are declining. On those leaves, the leaf sheath, you'll actually see very distinctive black bumps on a bentgrass dead spot plant, which is actually the reproductive structure, the pseudothecia. It's not anthracnose. Anthracnose has black spines. These are actually black bumps on a leaf sheath, which are those pseudothecia, and they are formed prolifically on bentgrass dead spot and never seen on dollar spot.
And going back to the dew removal again, the question is, would you remove dew before applying a propiconazole-chlorthalonil combination?
That's a very good question. And I think really from the standpoint of propiconazole, it's obvious that in Dr. Noden's research that it didn't seem to have an effect. When you look at chlorothalonil, it did, and if you're using a tank mix combination, you know, I would say if you're using low rates of both products, you may be better off removing the dew first. If you don't remove the dew, generally what's probably going to happen in that situation is that the workhorse there is going to be the propiconazole, and then sort of begs the question, do you really want a tank mix under those situations? You might be better off than just using the propiconazole alone. If I were going to go with a tank mix, which I think tank mixes are good ideas, I think I would wait and let the dew dry off or remove it first.
Another question on identification. On occasion, they see dollar spot lesions that really dig into the crown and leave a significant pit versus the normal foliar blight. Are they dealing with a different variety of disease?
That's a very good question. I don't know if I have a good answer for it. I think I'll answer the question from two perspectives, and I'll make my answer short. Essentially, if you're dealing with dollar spot on annual bluegrass, Poa annua, it's very common to get that deep hitting type dollar spot symptom. Whereas on creeping bentgrass, often you get a shallower symptom that grows out very quickly. So I think, you know, in many cases, you're dealing with, if you look carefully, you're probably dealing with a host like Poa annua, which is very susceptible, and therefore the fungus causes these deep pits which don't grow out very quickly. On the other side of the coin, though, I'm not saying there aren't isolates which are deep pitting isolates or strains of the dollar spot fungus, and this is something that I don't think people have looked at too carefully. And it's an excellent question. It's something I think we need to look at because I know exactly what they're talking about. Those deep hitting dollar spot patches are really problematic, and once you let the dollar spot go to the extent where you get deep pitting, recovery takes really quite a long time. So if you're on Poa annua, you need to jump on it quickly. It gives you a little more time to put the fungicide out. But, you know, we need to look, I think, more carefully at other strains or isolates which tend to be pitting isolates as opposed to non-pitting isolates.
Now we have a question which goes to the formulation of products. And the first one, I'm going to combine two. The first one is, does it make a difference if the products that you have described are applied as a granular or a liquid? And the second one pertains to the formulation of chlorthalonil, whether dry or liquid is preferred.
Okay. As far as granular versus dry, I think in general, I mean, you can get good control with both granular formulations and liquid. The general rule of thumb in the past 30 years that I've worked with fungicides has been that, in general, if a granular product's going to work, it's going to take a higher amount of active ingredient per 1,000 square feet to give you the equivalent level of control. So generally, you're applying more fungicide to get the control with the granular, but you can do it as long as that granular material is a penetrant or something that's going to get absorbed into the plant. Contact granulars for dollar spot generally have not been very effective because they're really going into the thatch. They're really not being absorbed into the plant, whereas a DMI or a penetrant type fungicide, as long as it gets dissolved and gets taken up by the roots or the leaf stem or sheath, you get pretty good control. But even then, I think the sprayable formulations can get, you know, equivalent control at slightly lower quantities of fungicide. I think the other question was basically, did you reread the second part?
The second part was chlorthalonil and difference between its dry and its liquid formulation in terms of its efficacy against dollar spot.
Yeah, I think that might depend on the product. Basically, a lot of these different products have different stickers in there. I know that you know, we've run side-by-side comparisons with liquid formulations versus you know, say flowables, and really have not seen that much of an effect. Where you see an effect with any of these nuances would be where you have trying to use very low rates of products or extended intervals at low rates. And that's where you may see an effect at a mid-rate on a label rate, at a, you know, standard 14, 21-day interval. At that, you're going to see much of a difference between a flowable and a regular, water dispersible granular type product.
Has any work been done with Civitas on the early applications?
You know, that's an interesting question. The Civitas is somewhat of an anomaly. It's a product which has a very interesting mode of action in that it turns on the plant's natural defenses. It's a gene priming product. It does reduce dollar spot. It does reduce certain diseases. What I tell you, I'll be honest with you, there's so little information out there, data out there, that, you know, I would just say if you're using a product like that, use it in a very limited area. Test it out to make sure you're not getting phyto. We've seen phyto with that product in hot weather. We've seen some issues with sealing of a surface in hot weather with repeated applications. So right now, until we do more research, and we've only looked at anthracnose, until we do more research, I'd say, you know, the limited data I've seen from colleagues, I've tried to get as much as I can. I've only seen the limited data. It will suppress dollar spot. I would be very cautious and use it in cool weather. Rotate it with other chemistries until more data is out there, because there's very limited information out there right now.
How does we have several questions along the cut area. How does height of cut affect severity of dollar spot?
Well, height of cut, unlike you know, say anthracnose, I don't think height of cut has as big an impact on dollar spot as anthracnose would. Having said that, I think we tend to get more disease on fairways for two reasons. Fairways have a higher height of cut than greens, and therefore the leaves take longer to dry off, and therefore higher height of cut such as a fairway would have a longer leaf wetness period and greater conditions for dollar spot development. The second thing on a fairway, which is a higher head of cut than a green, is that you don't mow a fairway every day, so therefore you're not removing dew, and you get a greater chance of disease development. And then last but not least, and this doesn't have anything to do directly with height of cut, but it does have to do with disease development, and that is on fairways, you're just not pumping on as much fungicide as you do on greens. And I don't know of many people that have dollar spot control issues on greens, but I know a lot of people that have dollar spot control issues on fairways for the three reasons I just mentioned.
What are your thoughts about using zinc with the fungicide program?
Well, zinc is another one of those adjuvants which we've looked at for a number of years. It purports itself to do two things. It says that it'll allow you to use lower water volumes and get equivalent control, which is a good thing. And it says that it will extend the length of control. I would say that we've seen instances where we've definitely seen improvements in fungicide efficacy with products like chlorothalonil and propiconazole, where we use zinc in terms of getting equivalent control, let's say 1 gallon versus 2, which is a good thing. I also will say that, it's not a given. If we take data 13 times in a summer, for dollar spot, we might see an improvement in control with zinc maybe 3 or 4 times out of that summer, and other times no effect. We never see a negative effect of adding it, so, you might get a positive response occasionally. I think that's a positive thing. I really don't think we've seen instances where we've seen increased longevity of control. In other words, going from 14 to 21 days just by adding the product. So I think it has its benefit, if there are benefits, would be increasing the control at lower water volumes.
So it's a question again to removing dew, whether a mechanical method is preferred over a syringing method, and is there a difference in dollar spot development as a result?
Well, it's an interesting question. I think it's not only, you not only think about dollar spots, you also think about other diseases and how much you're applying. If you're truly a syringing, just knocking the dew off with a very, very light stream of water, then I think they're probably pretty equivalent as long as you have fairly good drying conditions. Mechanical removal of dew, though, is not adding any more moisture to the situation. So that's why I say if it's truly a syringe, very light, it's probably okay. If it's heavier than that, if you're using the heads and you're turning the heads, just one turn of the heads, so you're adding a significant amount of water, and you're probably wetting down the patch to the point where diseases like brown patch or pythium could be enhanced if you're doing this in the early morning hours and you have conditions that are conducive to those diseases. So I'd be less concerned about using a syringe for enhancing dollar spot. I'd be more concerned about using the heads to knock the dew off and enhance diseases like brown patch or pythium.
Next question was, so is thatch an abiotic condition that is a factor in dollar spot control?
To the extent that if you have too high a thatch or too thick a thatch layer, for instance, if you have thatch that's greater than, say, 3/4 of an inch, what you're doing is you're enhancing the probability that that fungus will overwinter in a very high population. You're improving the conditions for that fungus to survive in the off-season, and therefore, by reducing the thatch below, say, 1/2 inch or 3/4 of an inch, you're taking away some of the cover for the fungus, and that should translate into lower disease development. So in that respect, it's an indirect effect on the fungus.
Will dollar spot spread rapidly after aerifying?
I honestly don't know if that's true or not. I would say this: if your aerification is done at the time of year when the turf is weak, and the aerification will weaken it further, then yes, I would say we would set the stage for more dollar spot. If, on the other hand, you're aerifying in, say, the cooler weather when the turf plants are nice and healthy, and you have sufficient fertility to allow those aerification holes and wounds to heal over quickly, I would doubt that you're going to see increased dollar spot. And in fact, aerification being a good agronomic practice, if it's done at the right time of year, done properly, it's going to improve rooting, it's going to improve turf quality, it's probably going to translate into less dollar spot in the long run.
Just like the last question is, can you recommend a systemic granular fungicide for dollar spot that would work on Kentucky bluegrass?
So, typically, there are penetrant fungicides and granular formulations for dollar spot control now. Products such as some of the DMIs are currently out. I know that landscapers use these, even homeowners can purchase them. They're effective in that they will control dollar spot. They are penetrants, but again, read the label because they're going to take substantially higher AI rates to control the dollar spot than simply a spray formulation. But yeah, there are products out there that you can purchase. A good example is the DMIs, and they are available in granular form, and they will work. Even the 5-8-methyl type products are available in granular form and will suppress dollar spot when used as granulars as long as you don't have resistant strains of dollar spot to the benzimidazole.
Great. Dr. Clark, I want to thank you for your presentation. It's been very informative, and we've had several responses making comment to that. And again, I'll let everyone know that the presentation will be posted for future reference. And for those of you who are GCSAA members, again, you can expect to get the code for this class within 6 to 10 days, and your accolades points will be posted to your account. And the last thing is just a reminder of the rest of the schedule for this season. Again, I want to thank you for attending, and we look forward to the future presentations.
All right, ladies and gentlemen, that does conclude the conference call today. We thank you for your participation. You may now disconnect. Have a wonderful day.